Hello guys, hope you're doing well. I'm Said and welcome back. Last session we talked about the arcsine and arctangent formulas and we solved a few examples. Now in this video and the next one, we're gonna work on some more challenging examples. So stay with me and let's continue the lesson together. And if you haven't subscribed to the channel yet, please subscribe. Let's get started. Number 1, the integral of 1 over the square root of 1 minus 4x squared dx. As you know, the integral of 1 over the square root of a squared minus x squared or u squared du equals arc sine of u over a plus c, and the integral of 1 over a squared plus x squared or u squared du equals 1 over a arc tangent of u over a plus c. Essentially, our goal is to rewrite the expression so it matches the standard formula. So this one is a little more interesting because it does not immediately look exactly like the standard formula. So we use substitution. So if u equals 2x, so du equals 2dx or dx equals 1/2 du. And we know that u equals 2x. So if we square both sides of the equation, we have u squared equals 4x squared. Now substitute into the integral. We have the integral of 1 over the square root of 1 minus u squared and dx equals 1/2 du. Let's bring the constant 1/2 outside the integral. We have 1/2 the integral of 1 over the square root of 1 minus u squared du, and we know that the integral of 1 over the square root of 1 minus u squared du equals arc sine of u. So we have 1/2 arc sine of u plus c, and final answer is 1/2 arc sine of u is 2x, right? So equals 1/2 arc sine of 2x plus c. Number 2, the integral of 1 over 4x squared plus 1 dx. Let u is 2x, so if we take the derivative of both sides, we have du equals 2dx or dx equals 1/2 du. Now rewrite the integral. We have the integral of 1 over u is 2x, so u squared is 4x squared. So 4x squared is u squared plus 1 and dx equals 1/2 du. So we have 1/2 the integral of 1 over u squared plus 1 du. And we know that the integral of 1 over u squared plus 1 equals arc tangent of u or 1/2 arc tangent of u plus c, and final answer is 1/2 arc tangent of u is 2x plus c. Number 3, the integral of 1 over the square root of 9 minus 16x squared dx. So let u equals 4x. So du equals 4 dx, or dx equals 1 over 4 du. Now substitute into the integral. We have the integral of 1 over the square root of 9 minus u squared, because u is 4x, and if we square both sides of the equation, we have u squared equals 16x squared times dx equals 1 over 4 du, or 1 over 4 the integral of 1 over the square root of 9 minus u squared du. Because 1 over 4 is a constant and we can pull it out of the integral, right? Now use the general arcsine formula with a equals 3. So we have 1 over 4 arc sine of u over 3 plus c, and as you know, u is 4x, right? So we have 1 over 4 arc sine of 1 over 4 arc sine of 4x over 3 plus c. The integral of 5 over 25 plus 49x squared dx. This is a very nice challenge problem. We begin by factoring the denominator. So we have 25 plus 49x squared equals 25 times 1 plus 49 over 25 x squared, right? So the integral becomes the integral of 5 over 25 times 1 plus 49 over 25 x squared dx, right? So we have the integral of 5 over 25 is 1 over 5, and 1 over 5 is a constant and we can pull it out of the integral. 1 over 5, the integral of 1 over 1 plus 49x squared over 25 is 7 over 5x whole squared dx. Now let u equals 7x over 5, and if we take the derivative of both sides, we have du equals 7 over 5 dx, or dx equals 5 over 7 du. Now substitute into the integral. We have 1 over 5, the integral of 1 over 1 plus 7 over 5x is u. So we have u squared, and dx equals 5 over 7 du. And we know that 5 over 7 is a constant, so 1 over 5 times 5 over 7 times the integral of 1 over 1 plus u squared du. And final answer is 5 and 5 cancels out, and we have 1 over 7. And as you know, the integral of 1 over 1 plus u squared du equals arc tangent of u, and we know that u equals 7x over 5. 7x over 5 plus c.